En el 2015,
GeneXus 25 allowed me to have a talk because shortly before I had attended some conferences and something had caught my attention. Basically, two things that were happening then. One was microservices, and I came across that word, which surprised me, in fact, because not that I heard that word, but they showed very many things, Netflix, Uber, and those were the two players that started with that story. And then I said, well, apparently there must be something interesting there. But we always say, well, uh, not because Netflix or Uber companies do it. That doesn't mean necessarily that has to call our attention here in the GeneXus community. But of course, you have to pay attention. The other word was Kubernetes. Again, at that time, there were several competitors, but there was a big force around it. So I talked about that a little bit then, about big data, and there were trendy words then. This talk is called State of System Architectures, which is extremely ambitious and perhaps too big for the name, because I'm not going to talk about everything that the present architectures involve. It would be impossible for me, from everything you have to know about it, and some topics exceed my knowledge. Perhaps the other members of my team have it. But this is a follow-up of those things, particularly microservices. The reason is that I've come across the fact that it's not only what Netflix and Uber were doing, but it's that they had faced the same problems under certain circumstances. Those same problems were now being encountered by us and other partners and customers, and they are coming or they are meeting some of the limits that those companies had faced because of other reasons. So those names started making noise then. And what do we do with GeneXus? What's this? So this talk is not going to refer to GeneXus, but some of the things that are happening, and analyze together some of the problems that we'll have to solve in the short term, or perhaps you are already solving them somehow, and we're going to see that there's no silver bullet for this. This is an image of Wikipedia, taken from Wikipedia, that tells you the state of the architectures at present. It's simplified, it's adding all those architectures that we had been centralizing, and everything that has to do with edge computing. I drew a simpler pyramid. And what we are probably doing, what you're probably doing, is this type of architecture. You're consuming something from the cloud. You're doing something with the cloud, getting a service from there, or having your data up there. You may be only there. Probably you have something hybrid, and you have something the traditional system, a data center interacting with that, taking and bringing in data. And there are some new players, probably, but in our mobile offline apps, we have data at the edge. Now, what happens is that we have agents asking for more data on the edge, that is in the border, at the edge of our systems, and they're consuming data. They're not only censoring, but processing data. This is, in fact, a simplification of what we've got at present. And around all this, we have the question of security. And we're not going to talk about it, but it's a question of security. When we go up to the cloud, well, we've got problems with security. Let's go to the edge. We have more security problems there, and more problems to deal with security and to deal with the things that we have in our traditional systems. If we go up to the cloud, inter alia, we're talking about infrastructure as a code, but when we get to the cloud infrastructure and put it in a code, we shouldn't put in the password, because otherwise we would be providing things. It's something very simple, but this happens to very many people. It seems obvious, but when we put our infrastructure in a code, we put in our accounts and we lose that code. And I mean, the question of security really encompasses all this. So I'm going to be talking here about an oversimplification of the system. We've got three vertices, and for some time you must have been making a distributed system architecture. You are having some kind of data in the cloud, you're bringing down, you have a data center that's consuming part of that, sending and receiving data. Most certainly, without knowing it, you are already making a distributed system. So the things that we have to take into account is, well, several themes, how to deploy those systems. And there you have Kubernetes, and that's established. It is the way it's established to make deployments. The question of APIs, the question of observability. It's not only monitoring and logging things because of security, because of edge computing. I'm going to touch upon very briefly the question of microservices and data sources. There's a whole track parallel to that regarding how architectures move in terms of equipment. That is, they run parallel. That's how the upsurge of the box is not simply good because we all have to work together, but this is very complex. And if we don't have cross-functional teams working from end to end, all this is not possible to be carried out, whatever the architecture. So it's full of articles, in fact, talking about from monolith to microservices, microservice architecture, and so on, that is making noise everywhere. And something that we love, that is to oppose it to something else and to see how badly we're doing things and how good these things are going to be. The first thing we say is, watch out, we are making the monolith. You are lost if you're there. That's the monster, and we look at it as something extremely horrible with many horrible things, but there are also some very many good things. What's something that's monolithic? Well, basically, oversimplifying it, I have all my user cases, all my scenarios. I deploy them in one unique runtime, a server. There may be different layers, but I deploy them all together, and they go to one large data store. Now, what's the following step? Something that's happened in the past 4 years is that no one thinks that I'm going to go from that enormous monolithic monster to microservices very happily. Everything's going to be separated. It's clear that we have to go step by step, very slowly. For instance, a term that I had heard at Ghana is this question of separating, at least logically, separate things. It's already a step. It's better than nothing. It's better than having all my user cases and not separate them in modules. Armin is going to be talking about how we can do all these things with GeneXus, but at present. But microservices, then I go on having a monolithic deployment, and we have data and then data store. My approach when I was preparing this talk with Christian Intamusu, I'm talking about, in general, things that books don't refer to. And it's a question of data, because there are integrations at different levels, at the level of the front end, micro front end, web components coming in to solve these things, the approach of this architecture is about the question of data and applications that are the ones that we do here. And you've just finished reading an entire book on microservices. You separate data, but they don't refer to the problems you know you're going to have and say, wow, what am I going to do? So these are mini services. Again, I keep the data store, and then the definition of microservices is, well, the micro, it's not that they are small, but it's that they solve a certain case, for instance, a credit request, and that microservice goes from end to end. You can read Fowler, any one of those who are specialists writing for the first time about this for quite some time now. It has its own data. The microservice is the owner of the data store. It's as if I had separated my data store. All those of us who have been working on systems and looking at systems and what people do, you wonder, how can I make this work? I mean, these things on their own, I mean, I'm going to start running it, and it's not going to work. Microservice is not a key that you turn on. This is microservice, and well, no, you'll have to work on it. And obviously, with GeneXus, we're going to try and go through a path to help you. We're going to walk you along that path. I think this is good, and we have to help you. The monster of monoliths is there, but also the monster of microservices. These are some of the microservices offering at Uber. Someone said, this is what I would like to know before having 10 billion microservices, because it's really an explosion of complexity to think that each one of these dots has its data with different teams and different languages, and that each one has chosen its own tools. Well, we are quite in agreement that that's not going to be something good, that we have to think about other things, and that in a certain way you have to look for ways out to come to an agreement. When it's all right, all teams have certain freedoms, but not all of them can choose what the monitoring tool is. And, you know, this is Uber, this is the monitoring tool. Of course, there are certain freedoms about choosing the language, but you know what? Everything that no is going to go to Go, and that's it. Because otherwise, I mean, we can't scale it any further. They had to make thousands of tools to work and monitor this. This is the observability of what's happening. And then these architectures start focusing on some nodes which are not that easy, and you still get monolith inside certain services. So the monolith has many things that make it appear as like a monster. But when we start analyzing many things in microservices, I've already used a monolith a bit better. It goes on being big. You can't put 4 of these lassie dogs in your car, but it doesn't bite. So, why then are we moving into microservices? Well, because there are real needs, and let's see which ones. Why would I have to go from monolith to microservices? Well, in the first case, I'd like to improve the agility of my team. I mean, about the delivery of things. Now, if you don't have DevOps, don't even there start. If you can't make the monolith, you're going to go into a complexity that's incredible. There's a dependence with microservices, what this is going to do, and so on. Don't do it. I mean, start by DevOps. That's in green because it's all right. I mean, at a certain point in time, I'd like to deploy a part, and then it comes to all the rest. That's all right. I mean, that's fine. Now, what happens is that sometimes, you know, I've talked to people, and it's going to move because of other reasons that are not really that good. It's good for certain cases when you use it, but I'd say, well, I have to move here because the availability of my system is complicated, and you mix everything, and data store is not it's not scaling, I haven't got availability. So I'm going to move and I'm going to go into microservices. I mean, that's what I'm going to try and analyze is some steps before going into that. Suppose that you have already set up your team and that you're going to move and you're going to start separating data. How are you going to do that? Let's suppose that you've got something that's quite simple, but let's suppose this could be at n. So we've got the orders. It's already separated logically. So we have orders, you have payment, and you have different modules about queries regarding the data store. What are the good things I've got here? Well, I've got consistency. Perhaps I don't have the availability I'd like to have, but there is consistency. We shouldn't forget what we have, right? I've got availability. All right, I may start having problems when you are making millions of queries and someone is inserting orders and you have millions of queries. The data store is going to be locked and I'm going to have problems. So the first thing I'm going to do, and that's why I'm going to have a read replica or a cache to the data store. Most certainly, most of you have it. So queries go through here and they jump on there. And as it happens in all caches, of course, I buy a problem when I'm going to refresh the cache when it expires. They're not that fresh. But as a government, this site isn't pulled down. If millions come in, I mean, I would put things in SD and I would use different techniques to separate. Now, consistency can be kept. Availability has been improved out of the read. You can read it. Flexibility, so. What you can see in this graph is what Fowler makes it a bit nicer, but it's this. Command query, responsibility segregation or something like that. I can't remember. That's the acronym. But basically it means that instead of the UI in case of reading and writing going along the same place, I can keep on the same data store, but I do something different for insert commands than for query commands. And so that solves something. In the case of the Mexican League, Football League, there are more reads than writes, the ones you do. There are millions of reads that will separate them. And if there is a cache, and if there is a process, then that would cater for the reads. And I could even turn off the database until there is a goal, until a goal is scored, and it would be fine, all right. I could have availability by simply making this case. But let's suppose that I would like to carry on with microservices. I'm not pure because my data store hasn't been divided. I'm going to separate it. And we're going to take the queries and the reads. Suppose I've already solved it. I'm now in the question of write. And let's suppose that someone is going to place an order and he wants to pay it. Now, if I've separated, and something important here about microservices, whatever type of separation you make, you have to have clear in mind what module belongs to what data. And so let's suppose that the orders are here, but payments of the orders are there. Orders that are paid they're obviously going to be a reference stating which order is paid. So whenever you pay an order that goes through the UI of orders, because I want to continue being consistent, I'll have to call through an API. That's the first thing you're going to do. You're going to put an API, and if I call the API and I'm lucky enough, the network's going to work and it's going to be consistent. However, this was like the SOA world. You call each service and so on. But the problem we had, and that anyone would see it when working with systems, is that practically everything becomes a remote an RPC is not the same as making a join against the database and the data, and you either want it or you don't, for the benefit of separating all this. Now, all this is an RPC, and that's why we have new protocols. New protocols are born because if everything's going to be through the network and this SOP, well, we're going to simply trying to separate service, but it didn't work. If we do it purely, everyone who tried it out couldn't solve it. It didn't work. So now we have new protocols, gRPC. It's going to be GeneXus supported. It's something that I can separate it, and codes are done in the same way as in remote or Cordova. Those things are coming back with different protocols, and those protocols are really going to work. That's what the creators say. Apparently it's working out. It includes it and so on. And we come to a stage where we can operate it through remote in Java.NET and other languages. And then look at history. We now, to try and do these things, since we've already distributed and to face commit is something that's going to give us availability, we go back to some ideas in the 70s about sagas, what we call sagas. What's a saga? What happens is that when I have to call payment, I have to call more services, I'm going to put it in sagas. I'm going to have a saga. I'm going to be calling in several things. And that's a question of what happens that if somewhere through something fails, and then that's a question of how to manage sagas. And that's something that we have to take into account. It's not that we can think that the network is never going to fail and it's going to be synchronic or asynchronic and it's not going to fail. It will. At a certain point in time, it will. And we have to know what we'll have to do. Well, the API where I send the mail fail, or whether it's paid or not, and that system, it thinks it's paid, and in this other one, it doesn't think it's paid. How can I recover? And if I did it there, and then I didn't get the response, so, well, that's a whole thing, and there's no simple solution. Someone can say, well, in fact, this is another pattern of event sourcing. We can do it because the problem with the API that is so synchronic is what happens if it's not available then, or if what I've said, well, I couldn't read the answer. I had given 200, but it didn't work out. So there are micro times. There is micro time in networks. Not everything works. And so the talk by Gonzalo Galotti yesterday discussed this, like having back streams, and I put in messages. Products like Kafka and others can be connected with a connector to the data store, and you can see what's happening there. It would put in data in the event stream, and so payment could be hang from there, and others as well to do other things. So what I'm putting in is events, and now I have an API that is asynchronic. In some way, we've created an asynchronic way for payment to find out that an order must be paid, and vice versa. Once it's paid, through a message, we go from one call to a subscribe. A subscribe to certain events to understand particular payment if there's any new order to pay, and vice versa. And, managing the state and so on. Now, the question of streaming is very important. You have to be careful that what may happen is that the order of things not necessarily are perfect. They may fail. You may not believe it, but the clocks play a very important role. Not all servers are always at the same time. GMT works quite all right, but you also have to be careful with those things. And at least to know what can never happen is that you have two owners of the data. And that's why it's so important about data owners. If something fails, which is the source of all truth. There can only be one source. Who says if the order was paid, it's that one? All right, we've decided that one. If this one didn't find out that an order was paid, then we have to go through algorithms that are practically running through and seeing that everything is in order, because at a certain point in time, things may not be in order. This is, well, the world is eventually consistent, and this is what this gentleman here says. There are many cases of eventual consistency that we can't avoid. For our industry, for data intensive, and I'm going to speed up because I know I'm running out of time, close enough is not enough for data intensive applications. You have to pay a check, you have balance sheets. Now it's true that in some schemes it is eventually consistent. To add it in a basket could be consistent. Perhaps when I'm going to pay, I don't have things, but you know, priority is given to availability. And when I'm going to pay, I have to be consistent. When I do my check-in and an airline company, I have to be consistent. That's why it takes time. But it's happened to us that you go with your ticket, and the ticket has changed. Some people, like Marcelo, are upgraded. I've never got it changed, but I know that people who travel, sometimes they get their boarding pass changed. Now, ATMs are eventually consistent. Why? Because they give a priority to availability. And how are they protected that they don't get out more money than the money the person has? Well, there's a limit, and that's a technique. I'm going to play in an eventually consistent world, so I'm going to put a limit, and I'm going to fine you if you overdraft. So those things limit those who want to play it unfairly. Now, what happens about data is that when we start talking about availability is, you know, in fact, you have to do away with relational data sources, and you have to do this or that. Now, it's true that there are databases that are specific for certain scenarios, and we see them in some companies, but not necessarily do we have to use them. And there are very many data sources. In the year 2000, there was an upsurge of NoSQL, and something that did very badly because it's not real. It's not real in practice. Builders are not real, and that's the CAP theorem. You can't have those three things at the same time: consistency, availability, and network partition. But since partition is something that is given, you can't have then availability and consistency at the same time. And that's not the case. And it's not the case because builders have already shown evidence that's not the case. In 2015, I showed that Google was doing some research that it wasn't worthwhile to lose availability in the hands of consistency. A relational database was issued by Google, and as you can see here, there is a scheme, SQL, consistency, availability, scalability, and replication. And there are some limitations there in the SQL standard that it's using, but Microsoft this year issued Azure Hyperscale, where you have the telemetry of 1 million cars with consistency and availability. Well, we can talk about that, about the theorem. We're not going to talk about this today and now. But this same data store, Microsoft put it in the cloud, and the case is wonderful because that's the way Microsoft attacked this issue. It's a relational data store with high availability, high scalability, and consistency that's in the cloud. And it's the same in every traditional system. Remember the triangle I showed you? It's in beta. An SQL for the edge is in beta. It's an SQL running on the edge, because in the edge is where the data store is going to be. And that's exactly the same there. And what you have below that, you have a group, store, stream, Graphos, etc. To conclude, look here. I don't think that anyone will show me an architecture and I'll tell you that the architecture is wrong. What I could do, if it's useful for you and you are being agile and you have the availability you have, that's all right. Of course, you have to plan a little bit ahead and see what the input you're going to have is going to be. What is the load that you're going to have. You can consider characteristics of the existing data sources in the market before moving to a scenario of eventual consistency, because I'll have to solve other problems first and I have to be careful. Basically, the problems aren't solved, they're changed for other problems. At GeneXus, we will have to look and see and ask you what is the level of consistency for your data, because in that way we'll be having more information about what architectures or technologies we can suggest. SQL at present is the best way to query all data sources. Amazon has just released PartSQL, which is a standard SQL to consult all data sources that Amazon has. For builders, for those of us building things and making systems that you really, we needn't worry. We can read the theorems, but we have to understand reality, and that's far more important. You are the ones that are building systems. You are the ones that will make a better GeneXus. Ami will be telling you about some more specific things about how we can go through these layers from the monolith to microservices. Thank you.